This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Yeah. Okay, cool. Thank you. Okay, everybody. Oh, hang on. Okay, welcome to Lecture 7. Today we're going to be covering arrays. Oh, it's pretty dark, hey? Let me just get a little bit better. Better like that? Like that? Good. Yeah, so today we're going to be covering arrays, but before we start on today's lecture, there's a few things I'll need to cover to go through with you to ensure everyone is having a good time with assignment 3. There's some issues there, and also there are, depending on how well you're doing, at the end of this week the actual project is going to become live, so the main project for this module will be available. The main project is a big chunk of your work, and it will take a good effort to complete, and it involves two parts. So the two parts is that you do your code and you provide the class files that are necessary, and the second part is a little bit complicated, and last year it was a minefield. It sort of didn't work as well as one would hope. But you will be submitting what's called a peer review. So what will happen, and we'll have to be very clear and concise with how this happens, what will happen is that you will submit your work to a peer review submission system on LMS, and after you've done so, and only after you've done so, you'll be in the sort of lottery, if you will. And what that means is then everyone who's submitted onto the peer review, your work will be scrambled and distributed 3 works to each one of you, and what that means is that you will get 3 works as part of your submission. You'll have to assess 3 pieces of work and give your feedback. The information on what you need to do will be given to you clearly in a script, but the project, the main project involves 2 steps. One is to do the work yourself, and 2 is to review 3 of your peers. There's a lot of information that you'll need to sort of work through, in the sense that when you submit for your peer review, you want to take away all your names and your IDs. You don't want to have your student IDs on there. You don't want to have your student name on there. You want it to be anonymous. And the student review that you get, so let's say I put my work in and my work gets reviewed, I don't lose or gain marks from that review. The reviewer gains marks for their ability to understand the code, to decipher the code, and to give professional constructive feedback. So the marks for the review is only for the reviewer. So you don't have to worry, nobody will be marking or judging you on your work. That will be done by a team on my side. But the peer review is something that will need to be done by a certain date. So in terms of your assessment, after the assessment, last year, we tried to give a day for all submissions on the peer review to be submitted, and then for those reviews to be distributed. This was to sort of speed up the process, to allow everyone to gain 3 submissions for them to review, time to review it, and then to gain their marks. It didn't work because a lot of students were busy, a lot of students didn't submit on time, so the distribution pool was very thin. This year we're going to give a longer duration, and I will send email nagging emails to you all. I'll be saying, "Oh, get your submission in, get your submission in." Even if you're given an extension, so even if you've been ill or something like this and you've been given an extension, by the time the peer review comes, whatever work you have needs to be submitted, because the person reviewing the code needs to have work to review. I'll remind you more again and again as we go closer to that date. That will be part of the assessment. So submitting once for your submission, which will be your code with all your bells and whistles and everything that's required. And then the second submission will be for peer review, which is anonymized. You take away your name, you take away your student ID, and you submit it as an anonymous file that then gets reviewed. Does that make sense to everyone? Are there any questions on that point? Everyone happy? Okay. Another thing is assignment 3. So at the beginning of this arrays lecture, I will go through part of the assignment 3 submission system, just because there's been a few questions. Hopefully I'll be able to guide you a little bit more, especially on getting it to work in NetBeans, because it can be a little bit tricky for some. And there also, I think there's some server issues. Yes? Sorry, can you not hear me? Sorry, what? Take it back. Okay, thank you. I think it's working on these things here. Okay, thank you. Let me just see what's going on here. Aha, thank you. Yes, there we are. Is that better? Okay, thank you. Do you know, I appreciate the feedback because I can hear myself fine. Anyway, okay. So let's recap on last week. Last week I saw lots of faces, like as if I was going to run you over in my truck, because we were talking about the copying and stuff, and it wasn't so very clear. And because I knew what was required to show you an example, I waited to make an example for you at home, and then have brought that example into Showcase and run through it with you, so that hopefully it makes more sense. So we were essentially copying these mutable objects. So these are just some of the slides. I'll just nip through the slides showing that we were looking at defensive copying, we were looking at copy constructors, we were looking at deep copying, and essentially what all this was meaning was that I was trying to convey the concept that if you don't provide copying as a means to avoid having your work modified, then you can fall into the trap of actually not being in control of the data, right? So let me show you an example of what that actually entails. So I've created even, let me pull this over here. So I've got a few things here. I'll go over that in a moment. So we had this missing persons example that we looked at. And this is a normal missing persons example that is utilizing this person. Let me just pull up. Okay, so we have a person class. A person class is an object of type person. And the person class has two attributes, that being first name and family name, right? And then we want to create a missing person object. And that missing person object then utilizes the persons object as part of its system. And in this case, we have the missing person that's creating a seeker, a location, and a sought person. And the missing person takes care of making sure that two of the attributes are always occupied or have values to ensure that the system doesn't fall down, right? So the idea is that you gain information for your missing persons program, and that can you see it properly? Is it? I see it. Do you want me to make it bigger? Yeah. Okay. Oh, wrong one. Wrong way. There you go. Is that better? More? How's that? I need some feedback. Does that work or too much? There you go. Is that okay? Yeah? Okay. So this missing persons class object, if you will, is taking care of making sure that certain things are done, right? So, you know, like if you want to ask for someone's phone number and you go up to someone in the street and you say, hey, not in the street, someone you know, and you say, hey, can I have your phone number? And they go, sure, it's cow, sheep, dog. You'd be like, yeah, I want your phone number, right? You'd immediately be verifying that number wasn't a number. Well, I know you can use letters these days. But anyway, the point I'm making is that you need a verification. So in this case, the missing person application is verifying that certain values are present when the objects are created. And it simply does this by having an if statement. So this is the constructor. This is a missing person class. Missing persons class. And in there it has 3 values. This is the actual literals or the values of the object. And then the first thing it does is it runs the constructor. If you remember, when you make an object, you create a new instance of any object. The first thing you always do is you call the constructor. Whether you make one or not, the constructor is called. In this case, we've made a constructor, and the signature for this constructor provides 3 values. The values are of person, 2 person types, 1 sorts and 1 seeker, and a string type, right? And the first thing it does is it then checks to see if a certain condition is met. If that condition is met, isn't met, then it simply gives a missing information error, if you will, and exits. Okay? So when you create a missing person, it needs those values. And if the values aren't there for good reason, the program terminates. If the values are there, then it just makes the object, and it's done, so you can utilize the object. Does that make sense? So far, so good, right? So what we were saying was that this is dangerous because it enables you to manipulate those objects without utilizing the missing person class. So what I've done, I've got the person class here, which I just created. It's a generic person class. The only addition to this is this copy part, which I'll go into in a minute. So I've got the missing persons class. I'm running my application, which is utilizing this. So I'm making a copy here. So what I'm doing, all this class is doing, it's small again, isn't it? Right. All this class is doing, I'll talk you through it. Ignore this. This is just a way of avoiding using the static keyword, which I didn't want to utilize, so I'll just hide that. So what's happening is I'm running copy. So this copy is the constructor. This is being run. And this is calling a method called makeNull, calling a method called new, and calling a method called makeCopy. Okay? So for now, I'm going to comment out this one, this makeNull, because I don't want it to crash. And I'm going to comment out makeCopy. And then I'm going to show you, first of all, what makeCopy it comprises of. So what's going to happen, I was going to point, you can't see me pointing on there, can you? So this copy Java simply makes a person called Bob Smith, makes another person called Jane Jones, and then wrong one, that's the make copy, make new, same thing, makes the 2 persons, then it creates a missing person, right? And missing person provides the P1, the field, because it's in a field apparently, and not to be confused with the word field for an attribute, and gives the P2. Then somebody comes along and tries an attack, which then they attack P1 and P2, or P2, sorry, with the first name and the family name, even though the missing person, we're only working on the missing person. So what I've also done, just to make things tidier for you to look at, I've created a method called output. Okay, this is just me making things simple to look at, and let me show you what output is. Output simply takes any object. In this case, it's a missing persons object, so you can see it's type object. We'll go into those later in later lectures, and it simply prints out the toString. Okay, that's all it does. So it just prints out the toString. I've already modified in the person. This is why I didn't do it on the end of last lecture, because there's a lot of work. I've already modified the toString of person to provide the first name and family name. Okay, so far, is everyone following along? If there's any questions, do ask, because you will need to understand this. Okay, so output is just a fancy way that I'm doing the prints. So I'm not having system.outprintln, system.outprintf, and all this. It's just a way of doing it in one place. I can hide it, it's gone, and then all I say is output and the constructor of any object that I want to throw at that method. Okay, so let's look at what's happening. I'm creating 2 people, person 1, person 2, and then adding those people to a missing persons program. And then I'm saying, look, show me missing persons, the missing person file, that particular instantiation or object, that version of that object. So it prints out that, and then I have some person who decides to attack. So there's an attack going on saying, look, I'm not going to touch missing persons. What I'm actually going to do is I'm going to attack the people that have been generated in missing persons, and thus bypassing the missing persons safety feature, if you will. Do you see what I'm saying? So I'll show you with an example in a second. So then I do the attack, and then I just print out missing person again. So what you'll see is the output as it was meant to be, and then you will see the word attack, and then you'll see the output as it is now. Right? It's pretty straightforward. It's simply saying, look, I'm bypassing missing persons even though I'm not touching missing persons. And all I'm doing is printing out missing persons and missing persons. I'm not printing out P1 or P2. Okay? So hopefully, let's make new. I'm just checking. So I'm only going to run make new. So I'm going to run it now. And let me just pull this up a little bit. Oops. Okay. So running make new. The first output of that toString was seeker from person Bob Smith. Oh, I'll remove those. Obviously, yes, the wrong way. I'll fix that now because I'm a bit OCD. Slash was the wrong way. Let me run that again. Okay, you didn't see anything. Okay. Okay, so you can see it's printing out Bob Smith. Then you have the attack, which is only attacking the person object. It's not touching the missing persons object. And then suddenly you can see that Bob Smith is searching in a field for you lose, haha, you'll never find me. Probably not the kind of outcome that he was expecting, right? So that was the first instance of not protecting your values, as I was trying to explain. So what I did then was I created this make null just to showcase. In fact, what I'll do, I'll put this underneath this one so it runs both. So now what I've got is I'm going to run what we've just run. It's going to give you the outputs. Then I'm going to try and make another version, but I'm going to be providing a null. What null is doing, if you look over here, is simply, what is null doing? It's providing this value here. I don't know if you can see that. So it's providing a no entry, a no location. It's empty, right, for the location. And if you remember, missing person is looking for location is empty. If it's empty, then it crashes, right? So when I run this now, oh, you can see the first value, make new, was running fine. Did that, showed me the attack. Then I try to make a new missing person. And you can see that it's already caught that. So the catch element works, but it doesn't safeguard against an attack on the object that it's being utilized because we're not copying. So I can still see confused faces. So to try and help you understand that, I've then written another copy class to show you how it should work. Okay, so let me, oh my gosh. Right, so then I created, that was the make a new version. Then I've used a make a copy, and all this is exactly the same thing. So I'm running exactly the same code, but this time I'm running my copy missing persons version. So the copy missing person simply does the same thing as the other one did, but if I compare them, so you've got where this is the missing persons, the original one, and it was simply taking the value that's been provided in the constructor and storing it as the object on instantiation when you're creating an instance of that object, right? That's all it was doing. The new version does exactly the same thing, but it takes that value that you're being given, and now it actually makes a new version of it. Just using the keyword new. Instead of being seeker, let me show you that comparison. See, this, I'm looking at this line. This was the original way, the simple way of doing it. Seeker equals seeker. And the new way is simply saying seeker equals new person seeker. Now, there was two things I needed to make that happen. The first was to make the new object, right, and pass the seeker that's been provided, same information. But in the person object here, I had to create a second, let me make that bigger, a second constructor, which you can do called overloading. And in this one, instead of taking in the two values of first name and family name, like the original one did, I simply take in the object person, which is of type itself. So you can do that. You can have your own, you can use your own type, if you will, if that makes sense. And then that allocates the value that's just been provided to it. So if we go back to copy missing person, I'm making a new version called seeker. And then I'm running the same thing I've just showed you again. So I'm doing exactly the same thing. I'm running the code, I'm doing the attack, and then I'm showing the outputs. So let's go back to copy here. And I'll uncomment this. So now I'm making the copy. I'll move this to the end so that it doesn't crash until the end, because otherwise it just exits out. So now I'm just moving the crashing to the end. And I'm going to run it again. So all that's happening is it's the same code, but this one, so if you look at make copy, which is here, it's running the same code as, oh, you can see P1, missing person, output, attack, haha, you lose. It's doing exactly the same thing. There's no difference, right? So it's exactly the same thing. So when I run this now, you get the crash, because that's something we had planned for at the end. So I'm running make new. It does Bob Jones, location, field, sort person, Jane Jones, Bob Smith, sorry, Jane Jones. Then it does the attack, and you can see that the sort person has been modified. I'm running exactly the same code again, this time using the make copy. So all I'm doing is changing that attribute, make copy, Bob Smith, field, and Jane Jones, so it doesn't change it. I'm not sure if that makes sense to you, but I will put this, well, you'll see this anyway on the recording, but I'll also put this as an example for you to look through. But that's basically defensive copying to make sure that nobody can manipulate the code outside of your conditions, the methods that you create to protect the data. Does that make sense? Any questions? Now would be a great time to ask if you have questions. Everyone happy on that? Okay. Let's move on. So let's talk about arrays. Ooh. Oh, before we do, oh my gosh, there. Before I do hit onto the arrays, I'm understanding that there may be a server submission issue that I'll resolve over this evening on the submission for the assignment 3. So if you're submitting assignment 3 and you're not getting your marks, I think there may be sort of an issue that may need resolving, similar to what happened in the first weeks. So if you're one of those students that have experienced that, rest assured I'm aware of it, and it will be dealt with very, very soon. But for those that aren't aware of it, just keep working hard and get the submission in, or get the submission ready to be submitted as soon as you can. Okay, so we've looked at variables, right? So we know about variables. We're constantly making variables. Sorry. Before I do go on the arrays, we'll get through everything, don't worry. I do want to just quickly mention the testing code. Now, some of you have emailed me to explain that you can't get your checker.class file to engage with NetBeans. And if you're among one of those that are struggling to get it to engage with NetBeans, I've not used NetBeans for this purpose. I normally just code in a different way for this type of thing. But what you do is these steps here, you follow these steps, right? In NetBeans, you create on your project. So you go to File, you go to New Project, and instead of choosing an application, you choose a class library. Okay? So you choose a class library, you give it a name. This is a way of packaging that class into a usable object. So you make a class library. When you've done that, it produces, let me try and find it, blah. Oh, yeah, here. So this is the one I've created before. It produced this library here. And then all you do is you drag and drop your class file into this default package here. So that's all I've done, is I've gone to my folder, I've grabbed the class file, I've dropped it in to here, and then that's created this checker resource, if you will, library resource. Then I've compiled it, so you can click on one of these little brooms. You can see what I'm saying. Click on these brooms or this hammer, or you can just go to run clean and build. And what that does is it generates a package, like a little package that you can do something with. And then all I've done is I've taken this Java library package and dragged it into my library's default package here. So I've grabbed that, dragged it into my libraries, and voila. all the errors. So the errors that I would normally have under here, with a little red line saying I can't find it, are gone. And you can use that class as if it was part of your code. So if you were to type in check dot, you can see now it's giving me the values that I need. The get column, the get rows is red, move, very much the same way as you would have in this script. Any questions on that? Everyone cool? Okay. So I'll put this up as well for you to review on the LMS, but the steps are pretty much there. That was a quick Google search to get the steps as clear as that, but it is just generally making a library that you can utilize. If you're not using NetBeans, you may not have this issue. In fact, if you're using something trivial like Notepad or something similar, then you can just Java compile, and it will be fine as long as the class file is inside the same file as your work. It would be fine, and you wouldn't have the issue. Okay, so back to arrays. Ooh, hang on. Okay, so for those of you who don't code, what is an array? Essentially, an array is a list of variables that are stored under one name. That's the kind of basic crux of an array. Almost like, I used to be, many years ago, I used to be a postman, one of my first real jobs, if you will, as a way to finance various aspects of my life. And it's like a pigeonhole. They call them pigeonholes, square boxes where you put letters, right? So you put all the letters in order. And that's what an array is. It's basically a name that you can access a list of locations as long as you need. And the key about arrays is that the values, this is driving me mad, the values on the arrays are all the same type. So you have the same type of values within that array. And you create an array in much the same way as you create a variable. You essentially give it a name, but you give it the default array syntax, and then you put your values in just as you would. So as an example, I'll use this checker one here as the testing code as an example. So if I was going to create an array, say if I was going to create an int for a start, just called Bob, you would just do this, right? So you know this is how it's done. You can create the object, or not the object, the value, and you can utilize it later. Bob equals 2, and Java's happy with that. You're all familiar with this. You can put it on the same line, where you can make the value Bob equals 5, so you can make an instance of that, and you can populate the values within that on the same line. And you can change them later, right? Very simple. That's how variables work. Arrays work in exactly the same way. The only difference is that the first thing you do is you have to put in these little square brackets, and that tells Java that this is now going to be an array. So Bob is now no longer going to be a variable. Instead, it's going to be a list of variables of the same type with one name. Okay? Now, there's two ways to create an array. The first is to create it on the same line. So if I wanted to create this and give it the values that it will have immediately, I would simply use the curly brackets, and inside that curly brackets, I put in all the values that I need. Okay? So I've created an array called Bob, and I've populated the array with, I don't know how many values there, nine values. In one shot. Now, the first thing to know about arrays is that an array is immutable, but it's mutable. What I mean, essentially you can't change an array once you've created the array, but you can change its contents, right? So when you create an array of, say, 10 elements, then you're stuck with 10 elements under that name, unless you want to create another array with the same name and more or less elements. And in so doing, you're essentially deleting the old array. You're not changing it. It's been deleted with the garbage collector, and you're then using a new version in a new memory location, doing new things, right? So this is essentially the first implementation of an array. And to access, so now I've got an array, what can I do? What can you do with that array? Well, the first thing you can do is you can access the array, that'd be the first thing, by simply giving the value of the location in which the element you want to access is kept. The value, I know most of you know most of this already, but just as a means to keep it kind of at a certain level to bring people up, I'll go through it anyway. Each element inside the array has a secret value called an index. And the secret value, I call it a secret because you don't see it, but you can call it. And the secret value always begins with 0, and it always goes to the nth, or the length of that array minus 1. And the minus 1 is there because it doesn't start from 1. So you have to shift everything by 1. So what does that mean? Essentially, in this example, this would be 0, this would be 1, this would be 2, 3, 4, 5, 6, 7, and that would be it. So these would be the index values of those elements inside that array called Bob. And to access those elements, you simply would put in the index, so you'd call the name of the array, which is called, in this case, Bob, and you would give the index value of the element that you wish to access. It's pretty straightforward, right? So you would say, let's say we want to access 5. In this case, we would say, what value would we have to put in for 5? Shout it out. Index 4, yes, exactly. So to access index 4, we would do this. Now, what I'm going to do is I'm just going to put a system out so we can see what is in there. So what we're expecting to see when I run this is the value 5, right? So can you tell me what value I need to get 78? 7, right. So there you go. So that's value 78. So you can see all I'm doing, putting this aside, is just calling Bob square brackets and putting in the index value. Straightforward. Now, arrays are not objects. They kind of act like objects, but they're not objects. They're completely independent values, almost like it's a type. It's a type of data or a type of data structure. And whilst they have some attributes that you can call upon similar to an object, they're not objects, and that's something to be very clear about. So let me go back to the slides, just to keep me going in the right direction. I do get carried away with the coding, but I've had a lot of feedback saying that the coding is very helpful, so I'll keep doing it. So you define the variable of an array type, and then you provide, or you pass the arguments to that variable, which allows you to create it, right? So you've got the base type, which can be any type, primitive or object. So you can, the power of it comes from objects, actually. But you can call any type of value. What do I mean by that? So I can type in, for example, string Sue, and I'll just do it like that just to show you. You can just do string Sue, and now I've created an array of strings, right? But this particularly array has a null value, so there's no values in there. And the same thing, because which class am I in testing? Where's testing? Okay, yeah. So I can have checker C, well, checker. So now I can have, for example, checker C, which is an array of checkers, because this particular class was the one I showcased utilizing adding the checkers to my NetBeans implementation, right? So what I'm highlighting is that the type here is the base type. So this is the base type. Then you have this square brackets, which indicates that you want to access the array field, or you want it to be an array data type. Then you provide a variable name, which is what we're doing here. And then this here, implementing the variables now at this point as you're creating the array is the only time you can do that. You can only do it on instantiation. You can only do it when you're creating the array. What I mean by that is that I can't then, or at least I say that, but I think it was java7 I last tested this, so I can't then say Sue equals this value, as far as I am aware. There you go, so it's giving me an error. Now, if I was to say it's not, let me put it here, oh dear Lord. Let me do the same thing on checker. Oh no, checker won't allow it. Let me change this back to an int and change this to an int. You can see that it's not because these are integers, but you can see that it's not because they're the same values either. So Sue is not allowing it to happen because I've now gone onto a new line, you see? I've stopped the implementation of creating the array, and now I'm moving on to something else, if you know what I mean. So if you don't create the size, if you don't provide the values of the array when you're creating the variable of the array, you can't utilize these curly brackets to fill your array values. Now, if you don't, let me show you the other way. So how would you do it? That's the next question, right? How would you fill the array, or how would you give some meaning or values to those arrays if you can't use this? So let's say you didn't know the values. You're going to ask the user, how many values have you got, and can you give me those values? Well, in that case, what you have to do is you have to use the new keyword, just like you would with an object, and then you have to then provide the type, the int, and then the square brackets, but this time you have to give it a value. So this is one of the limitations, and also the positive things about an array, is now that you have to give it a value and define its size. So in this case, I'm saying, later on I'm saying here, I want to have an array called Sue that holds ints, and I'll tell you how big it needs to be later. And then you do all your code, blah, blah, blah. And then later you think, aha, I now want to create the array because I'm going to have to use it later. So then you say Sue, calling back the variable, and you create a new value, and you give a fixed value. So that's a limitation, right? Because now you have a fixed value. And as I said, you can't change it. You can't make it bigger or smaller, not with a standard array. In later lectures, we'll go into some of Java's classes that allows you to have modifiable arrays, but we're focusing on the basic array right now. So, so now you've got a situation where you have 10 elements stored under the name of Sue, and they're accessed through their index, right? But at the moment, they have 0 value, so every one of them have got 0. There's no value in there. Excuse me, beg your pardon. Because just because I've created them doesn't mean that they exist. They're just empty. They're just empty values that have nothing to show. And in fact, I'll show another example later. So this is how you create. This is how you can create. Not that you have to. This is how you can create an array immediately if you know all the values. This is how you create an array generally if you don't have those values. And it's the same way. You would then say Sue, and you'd give it some value, say 5, which would be the index. That means the location starting from 0, if you recall, up until the length -1. And then you can give it some value. So let's just say 45. So what I've done is essentially just chosen the 5th index value and put in a value inside that value for it to be utilized. Now, the thing to remember is that all the other values are empty because I haven't done anything with them. So it's your job to either fill or not fill, depending on the use of the array, the values in that array. Make sense? Any questions? No? Right. So it's the same syntax as I was mentioning, so, you know, as you would have the local variables and such. And if you want to return an array, so as we've done previously, let me tidy this up. In fact, let me get rid of that one. Now, if you want to create a method that returns an array, if you remember when you create methods, you say public, and you'd say int, and you'd have your method, my method, and that method would return say some value, right? And then when I call my method, so I'll system.out and I'll call my method. Ooh, okay, that's because it's not static. There you go. So if I call my method, what we'd expect to happen is that we would have this value 1. So this value 1 here is representative of me calling the method. Now, if you want to return an array, you simply put the squares after the int, and now this is expecting an array, right? So it won't return it. So if I was simply to choose this, for example, and put this here and return Bob, then it's quite happy. So to return an to return an array, all you do to kind of, I'm going to use a stupid word. I'm making this word up, so don't use it. I'm going to arrayify the method. Right? So I'm going to return an array. You simply add the square brackets. It's as simple as that. And the same is if you want to add an array. So if I want to have an array here, then you simply add the square to indicate that the type. So these two, this int or this type and the square brackets become one element, which simply says this type, but it's an array, right? And of course, this isn't allowing it now because it needs an array, but if I put Bob there, then it's quite happy because Bob is already, in fact, I should be able to put Sue there, even though Sue, okay, no, so Sue hasn't been defined yet. So Sue at the moment is just a variable. So if I was to say Sue equals new int, then Sue's happy. Even though all the values are empty, now there's a mass there, there's a size, right? So it knows how big of a value to transfer. I hope that's making sense. So that's what it's talking about. So you can just choose the base type, your method name, and your type name to enable you to transfer variables back and forth. So this is just going over what I've already covered, initializing arrays. So we've covered this already. So if you can initialize it as a constant, which is something that you should be considering doing in any instance. And this is the only time you can use this is when you're initializing. So when you initialize the array, this is the only time you can use those curly brackets. I do remember when I was learning, right? I won't tell you how long ago. But this did catch me out, actually. I didn't understand that you couldn't that this doesn't mean it's an array. This is an initialization process and only to be used as an initialization process. Right, looking at the time, let's have a quick 5-minute break and we'll continue thereafter. Okay. There you go. Okay, guys. That was the quietest break I've ever had. It's a good thing. Okay, so I guess we'll begin again. Something to mention about creating an array, initializing an array and filling the array value like this on creation is that the number of elements in that array depicts or defines the size of the array, right? So you can't change the array size later. So if I was to say system.out bob.length, it will give me, so this dot length is similar. This is not a method. You can't. It's not a variable either, even though it sort of acts like one. So if you say dot length at the end of your array name, it will give you the length of that array. So Java keeps the size of your array available for you, unlike in C. And once it's defined permanently. So if I was to say I've done a for loop. All I type there, by the way, all I type is for I, and I hit tab, and it will automatically see that I have an array above, and then it fills in that array for me. I'm not a really fast typer. And if I was to simply say of I, it should give me, that's an interesting one right there. It's giving me two values. I think it's calling the two string. So what we want is this less than bob.length, I equals. Now can anyone give me the reason why it's giving? Oh, that's because of these things at the end, isn't it? There we are. Okay, phew. I thought there was something weird happening in Java then. Okay, so I'll put that junk back in just because I want to keep it for you guys later. Okay, so essentially, all I've done is I've got my bob. I've asked it to tell me what the length of bob is. So let me just put in length, like that, so that we have it. So you can see the length of bob is 8. And then I'm iterating through bob, printing ln and the contents of bob in a loop. So this is how you will use it yourself. So you'll obviously iterate through arrays quite commonly. And again, this defines the size. Now, if I wanted to add a value, say if I wanted to have an int a equals 42, and I wanted to add that to the end of the array, I can't do that. If I try to access, so we now know that the array size is 8, right? But we know that the index is 8 minus 1, you see, because we have to factor in the 0. So if I was to say system.out bob of 8, like so, I'm going to get a common error, and you'll see this error quite a lot, which is the Java language array index out of bounds exception. So it's simply saying that you've tried to access an element that isn't contained within that that variable. You'll see this array quite often. If you don't, you're brilliant. It'd be pretty awesome. And another thing, so when you're doing this, if you were then to say, hey, I don't know how big this, I don't know how big the array is, but I still want to print out the last element in that array, then you could say that you want to have the length, Bob's length, but the problem there is that the length, as you saw with the previous example, is 8, which would be the same value, which would give me the same error. So the only way to have that is, as I mentioned before, is that you can only go as far as the length of the array minus 1, right? And that would give me the final value of the array. Does that make sense? Very straightforward stuff, yeah? Feel free, honestly, feel free to ask questions during the lectures, because that's the only way I can give you actual feedback, and often I find that what one student has as a question, other students also have the same question. So it's always a good thing to ask during the course of what I'm going through. So that's talking about the size implementation of an array. If you create it online, then on the same line, then you're going to be creating the size and defining that size at that time. Otherwise, you'll be creating an array in this way by using the new keyword. And if you create the new keyword, there are some conditions, and the conditions are that this value has to be positive or greater than 0. You could create it as size 0, and there are reasons why you might want to do that, but it's not common. It's not something you'd want to really do. But there are times when that is a useful feature, but it's not something for this class. So you can't have negative values either, so you can't create a negative array. I mean, it's almost intuitive, but if you're creating an automated array and you're taking values either from the user or from some source that you can't control those values, then you'd have to make sure that you don't have a negative value when you're creating the array. And another thing, so whereas I've got 5 there, of course, you can also use variables. So I could have integer, some value, equals, and you can give it whatever value you want. And then, of course, you can use some value here, right? So then that's going to create an array called Sue of size 100. Right? Make sense? Yeah. Okay. Now, when you do create a new array, you're not creating array values, as I mentioned. So usually Java just gives an inherent value of 0 for integers, 0.04 for floats and such. But the truth is, usually you'd want to make sure that you're initializing the actual array yourself before you use it. So don't just use those arbitrary values. So if you need a 0 as the value, it isn't good practice to put in low value knowing that it's 0. That's bad practice, actually. So you need to be explicit and give those values. So this is just going through what we've already said. Yeah, essentially covering what I've just gone through more excitedly with code, because I get excited with code for some reason. So the pitfall is the index out of bounds. So if you try and exceed the index either positively or negatively, you do get an index out of bounds error. So don't panic when you do see them. It is a common thing to have, often because you don't always create arrays of a specific size. Often you'll create them based on the data that you have at hand, and it's easy to make errors and coding issues in that way. So this is a typical example of creating what we've just done, really. So you're creating a final array of type int. It's called days in the month. I think, I thought I had an example of this, but it's for later. It's called days of the month. You're giving the values to this. Now, at this point, it's classed as final. Is that a good idea? What do you guys think? Is it a good idea to have this particular example as a final? Very good. Yes. So not really, because February 28, or sometimes it's 29, right? So we have to, but this example is making it final, just as an example, but it isn't a great example. I'm not sure when the next leap year is, but that will change in the Gregorian calendar. And then it's propagating some values of the month from the user input. And as you can see, this now sort of coincides with what you've already been using, right? So when you're using the args, you've already used an array in that sense, and that array is being generated on the fly, and it's automatically called args. So this is just an example of roughly what we've already covered, I guess. And array.length gives you the length of the array, and it's really common to use array.length to loop through an array, but you have to remember that the array.length is 1 greater than the size of the index value of the array, right? Make sense? Okay. Another common feature, which I've already gone through, so again, iterating through an array is normally you would use this I function here. Since Java 5 actually has another function, another feature which you can use, which I'll showcase in a minute. But before I do that, let's have a quick poll. Oh, so you don't have to have it as, you can go to bits.ly, bit.ly /T Christie. So have a quick poll. And let me get this quick poll up here. So the question is, what does this print? Now, this is the kind of question that would be a really easy question in an exam, right? So you might see this kind of thing, asking what does this print? I won't talk through it until the end, so that it gives you time to sort of analyze it and decide what the output is. Yes? What are you looking at? Interesting. Interesting. I think you've just changed a swarm of answers. It's a good point, though. Right, has everyone made an answer? Yeah? Let's have a look. I bet this will get me to log back in. Yes, it will. Why wouldn't it? Right. I'd be interested to know. Only 38. It's only 38 people in this room. I'd have sworn it was more. Okay. We keep updating. I'll keep updating. Come on, how many people's in this room? I'd say it's got to be 100, right? Okay. So majority saying 22, some saying C, some saying D, and 1A. So let's see what's happening. Now, yes, there is an error there, but I think that's a typo. And the reason why I think that's a typo is because that would be a compile error rather than a runtime error. Okay? So that wouldn't compile. So I'll make a note of that, actually. Slide 20. Yeah, that's a typo, but well done for spotting it. Now, assuming there was a semicolon there, what's going on in the code? So you're creating an array of size 3, you're creating an integer of 0, and you're saying for int of I from 1, which is here, to a the length, so a less than or equal to the length, equal to would be 3, right? So it's going from 1, 2, and 3, right? So it's actually giving an error because it's trying to access a field outside, and then it's doing what it does. So compilation error aside, the actual error would be a runtime error. But that's good spotted on that, and I will get that fixed. Does that make sense to everyone? Except for, actually, all C. So even, yes, a C would have been, 2 and 3. So the issue, so looking at the example here, so some of you said the answer was C, which is 3. I can see why you would have said that, because it would have added this up and added this up, and it started from 1. That makes sense. But the killer here was the equal to. So the equal to is saying, look, to the equal of the length is exceeding the index value. So that was the reason why that would fail. And D4 would be adding all of them up. So again, the issue here is that it started from 1, and all indexing in most languages start from 0. I'm guessing it's to do with binary and computer chips, why they began that, because logically it doesn't make that much sense, does it? But that's what's used. Okay. So, as I mentioned, arrays are mutable in the sense that their contents cannot be immutable, right? So you can change the contents, but the array size itself can't be changed. So the array itself is fixed, but the actual contents you can't. So if somebody gets hold of the value or the actual alias to your array, then they can do anything they want with it in terms of its type. So that's not good. You could have 100 days in January or 6,000 days in June. I know it sometimes feels like that, but hey. Again, it's similar to an object. Generally, arrays, you use pointers to point at the location of the array, because one of the things that arrays are very good at is storing objects, and as you know, objects can be any size, and they can be variable. So the location of the value generally, if it's not a primitive type, generally it's a pointer rather than, but you don't have to care about the pointer, you just care about the actual index value, right? And again, beware of privacy leaks. So if you don't want your values to be changed, don't allow any accessors, don't give any access to that variable, keep them private, protect the values in there in much the same way as we covered at the beginning of the lecture. Copying arrays, interestingly, is not a trivial task. It is trivial in terms of the size that we'll be looking at, but when you copy an array, you essentially have to copy the array element by element. Actually, when these slides were made, I guess there is an arrays library that you can utilize, but generally just using an array, like the type array, you have to copy it line by line. So in this case, you have this method is created statically, mainly because it doesn't have any instance variables. If you remember, an instance variable is a variable that's created when you create a new object, and a class variable is a variable that is part of a class, usually static. And in this case, we're not going to be utilizing an instant variable, so it's a good idea to have it as static because of what it does. You're basically providing an array, in this case of type string. You're making a new array inside that to the length of type string. You're copying each element in a loop from the original to the new copy, and you're returning the copy, right? So to copy an array, you actually have to go through each element in the array to copy it. So if it's just a small file of a few thousand or even a million, it's not going to be too laborious. But when you go into the billions and trillions, naturally, maybe using an array isn't the way to go if you're going to be copying it quite often. Now, as I mentioned, you can have, as I've already mentioned, you can have an array of any type. It's gone. You can create an array of type, of any type. So I suppose if we just use a string, so if you just have string, my string array, you can create a string of objects of that type. And what you can do with that is that you can implement any method available to the object on each element of the array, right? Which makes it kind of powerful. What do I mean by that? So if I was just to give an example, a real quick example, like so. So I created an array of type my string array, and on a string you have maybe a string is not the best option, but on a string you have a number of methods that you can call upon. Actually, I'll keep it as that for now. And this brings me to a different type of loop. It's not this loop, but you have a different type of loop that is available. Instead of looping through each element of each index, you can actually give the whole array through the loop and say, hey, for each element that's in here, just loop it, and for every one of those elements, become that object for that rotation. Let me show you what I mean. So if I was to say for string, for each string, and I'm just going to call it S, in my string array. Sorry, I'm going to fix that because I didn't like it there. So you can see this is not a typical for loop. So it doesn't have a counter, it doesn't have indexing. It just has, look, it just simply has the name of my array and the type of array it is, and then what's called a kind of like a local variable, right? So when you have this type of array, it's kind of a new type of array that came out later in Java. The actual premise of how it works is that for every iteration, for every single loop that this array, that this for loop generates, S increments between each value here. So S itself then becomes an object for that one loop. So if you've created an object class, like we have the people class or person, is it person class? I've got an example, missing persons class, or the persons class. If you did the same thing with that and you had an array of your persons, you could then call each person, give it a local variable name, and then act upon each person in that list according to the methods that you provide. Does that make sense? I'll try and give an example. So when I click dot here, you can see now I'm using this S is now a type string, and I can call upon any of the methods that are available to the string, right? There's obviously quite a few, but to make the example a little bit clearer, let me go to our persons copy thing. So we've got, let's go to copy here. If you remember this example, and what I'm going to do, I'm going to create a new, I'm just simply creating a new constructor called copy, and here I'm just going to have a boolean called B. I'm actually not going to use the boolean. What I've done is I've just sort of bypassed the signature because I just want it to use, I want it not to run this one. I want to keep that to give you guys as an example, and I want it to use this one, right? So all I've done is simply said I want you to make a new version of yourself, and I want you to use this value. So I've given a signature, provided the signature key, if you will, and it's going to use this one. So if I go back to quickly testing code and just take the string here and that, and go back to here, and pop this in there. Now what should happen, if I change this to person, oh, that's not very good, is it? Person, my string, and it doesn't like it because it won't like that. Okay, let me try something different here. Let me do it like this. Okay, so I'm going to do my person array, and I'm going to create the my person array. Ooh. My person array. I'm just going to say 0 equals. Oh, hang on. My person array. I have to give it the size first. I'm going to make it to size 2. Because new. Okay. Ooh, what have I done wrong? What's wrong with that? Yeah, nope. Can someone shout at me, what's wrong with that? Have I spelt it wrong? I did. Oh dear Lord. Okay, let me copy and paste that. So I say my person of element 0 equals new person, so that's fine. And I'm going to do the same thing, my person of element 1 equals new person. So what have I done? I said, oh, it's my parent. Oh my gosh. Can't have that. You guys have got to shout out, you know. I'll end up going home all stressed. Okay, so I've simply, instead of using type string, I'm now using type person. I've done that on purpose because I want to show you something. So what I've done is I've created a standard array, this time of type person. Person is a class that we've created, so that shows you what control. I've called it my person array. Then I said I want it to be size 2, so that's the limitation, it's size 2. But the positive thing about arrays is that there is no time when you want to search for an array index. It's immediate. It's one. You don't have to search. You literally go to that location. And then I then said, look, for the 0th element here, for the 0th element, I'm making a new person called Bob Smith. For the first element, I'm making a new person called Jane Jones. And then you can see that we can call upon for each iteration, so for each loop in that for loop, so I'm saying for person type, which I'm going to be calling, let's call it P, because it's not really enough. For person type P, in this loop, this is a local variable called P, my person array is the array I'm supplying, and for every one element in this array, I can then act on that element. So I can say system.out P, isn't it? P dot, and I can just say get family name, for example. And if I run that, you can see now it's saying Smith and Jones. So it's running through each element, the first element being 0, second element being 1, and it's just calling out the family name. Does that make sense? Anyone with any questions? So the power of using arrays isn't just in having a list, but it's having the capability of utilizing objects and going through each object and calling upon unique methods that you create within those objects to do some interesting tasks, right? So it's not just calling values of 20, 42, 68. It's actually doing things. You can actually call methods within those array cells and do things. So you can do really complicated things, which becomes really powerful, I think. I hope that made sense with that. Any questions at all? Anyone with any sort of... I'd be surprised if I've explained it that clearly. Okay. Yes. Oh. No. Yes, I see. A good point. I like what you've pointed out there. Okay, so no. What we're looking at, when I'm saying, so the question is this 0 and 1, I guess what you're doing is kind of comparing that as 0 and that as 1, right? All right. Okay, yeah, and that's a fair assessment to make. But the actual situation is that this person is independent of the array. Like it doesn't. So what I should do, let's make this 10, and what I could do to try and maybe make it a little bit more. I'll just put some random values so that they're all different, right? But you all know what it means. See, this is why nobody asks me what I should name their child. Okay, what have we got? We've got an error, oh yes, because, oh my gosh. So, right, so I'm making a new person of size 10. Is there any errors there that I've done? It's giving me errors somewhere. Where's the error? Why is it giving me an error there, guys? Oh, missing person. Okay. Let me get rid of that. I'll make new. Oh, dear Lord. I've opened up a can of worms, guys. Okay, I'll just comment all these out because I'm not working on those right now. Right, so far so good. Let's try that. No. Quickly, what is it saying? It doesn't like it because, which one's it not liking? It likes the Jones DFS. No, that's fine. It's happy with that. Why is it having a problem? Ah, okay. So what it's doing, it's actually hitting the, so it's hitting the end. It's the null pointer exception because I'm using an object of person. And if you remember from when we were looking at mutable objects and non-mutable objects, when you create an object and you don't define it, it returns a value of null. So what it's doing is it's finding a null pointer and thus giving me the null pointer exception. So 1, 2, 3, 4, 5, 6. So let's just change that to 6 just to appease the Java gods, as they say. So that if this was an array of integers, it would have just got zeros, and it would have just printed out zeros for all those empty cells. But because this is an array of objects, each empty cell is natively a null, and therefore when the array is running through the array and it finds a null pointer, it just gives me the null pointer exception. Okay, so going back onto your question, you can hopefully see now, even though the names are a little bit odd, that the actual index has no bearing on the contents of the object. So essentially what I'm saying is that person is this entire class or those two values, to put it into its basic terms. So it's simply talking about those two values as an object, and all the methods are the control mechanisms for that object. And that's how you control those two variables. An object is an object consists of its literals or its these values here. They don't need to be at the top, of course. So this object is literally just these two names. Everything else in this object is just a way of controlling those two names. And when you create an object, you create all the variables, and that object becomes whatever those variables are, whatever they define. They define some physical attributes for a real object, if you will. So going back onto the copy thing, this first name is simply an element in person called first name, and an element in person called family name. And it's got, so the index here is literally talking about the index of this container. And inside that container are individual objects of type person. And those individual objects of type person can be acted upon individually on each iteration using this for loop. Did I answer the question, or did I just sort of sidestep it? Does it make any sense? You sure? Yeah. Any other questions? No? Okay. Thank you for that. Yeah. Okay. Going back on to looking at the time. I was getting nervous towards the end now. I wonder why. Oh, you can't see that. Okay. So the example I gave you actually fits really well into this slide. So you can create arrays with any type of object, like string was an example because string is an object, and we've just used our own object called person. And when you create an object, it doesn't create any objects. When you create an array of objects, it just makes an empty space for them. Almost like if you get a new job in a really swanky business and they'll give you a parking space. It doesn't mean you have a car, right? You just have a parking space, and that's where you can park. It's the same thing when you create an array of objects. It just makes a parking space for each object. And it just puts the sticker null in each parking space. It's a really strange analogy, but hey, it puts a null in each parking space, and then only then when you create an object and you put it in that space does that object become accessible. And that was the issue that I just had. I created 10 parking spaces, if you will, if I can use that analogy, and I only created 6 objects. And there was 4 parking spaces that had nulls, and then when I try to run through all the objects, all the spaces, and it got to the last 4, it was like, nah, there's nothing here, mate. You're lying. That's not an object. That's just a space. That's got no within there. And that's what we had with that error. And that's, yeah, so that's something to be aware of. So when you create an object of type array, or an array of type object, should I say, then that object is defaulted as null until you make a new version, a new instance of the object, and put it inside the space. So you're all thinking about parking spaces now, I'm sure, right? Okay. Now, one of the limitations of an array, as we mentioned, is if you want to grow an array. So if you want to make an array bigger by, say, 1 element, you literally have to copy the entire array and add an extra element to a new array, copy the whole array over to that new array, and then add the final element. So in that example, you would have to make a temporary new array of the same length plus 1 if you're adding 1 element. So you have, this one's an integer called temp, new integer, the array. So we're assuming there's an array of an arbitrary size, right? We don't know how big it is. An array called r. We get the length, dot length of that r array, and we do plus 1, okay? And then for every element from 0 to the less than the length, so that's length minus 1, we simply take the I element of I, index I, so it starts at 0, climbs all the way up to the top, and we give the old value r of I to that value, and only then when you've finished do you then say temporary, the final version, the array.length, yes, the r, which is, if you remember, was 1 less than the new temp. We take the original length and we add the new value to that, and then to make the original name valid, so you can still use the original array, you simply say array, the old array, equals the new array. Make sense? Some confused faces. Don't be shy. Honestly, I do not bite, I promise. So essentially that's really inefficient, you know. What normally happens, and I've seen this a lot in projects, is that you will overestimate the size of your array. And so, for example, a friend of mine was creating a fluid simulation, and he had so many points that represented each atom in the fluid, and he overestimated something like 10 million cells, and then he would make sure that his the length of his array, he monitored with using a tracker, so he tracked the length so he didn't exceed what he was using. The reason he would do that is because, like I said before, it's very fast to access an array. It's simply, you don't search an array, you simply access the location you want immediately with one iteration, right? And then by doing that, he was able to manipulate data very, very fast. But obviously, copying an array is a different venture. You've got to go through every element and make sure that you're making a duplicate. So this is very inefficient. So doing one increment of an array is not something you should be doing. Over exceeding the size of the array, usually doubling is what people do. They double the size of the array to utilize it. That's something that's done commonly. Again, I don't think that's very efficient. There are other ways which we probably won't be covering in this particular class, but at least you know that's how it's done. Is there a question? Oh, I got excited. All right. Okay. So this is the concept I was just mentioning, having partially filled arrays, but you do have to maintain or track how full that array is, because you can have issues if you're using an object in the array. Then you can get a null pointer exception. If you're not using an object and just using arbitrary values like an integer or something, then you can end up getting invalid values because you've got like a billion zeros or something. So this is just saying what I was just saying. An example of that here, just checking the time. So this is expanding an array. You get the initial size. I'll let you run through this in your own time, but again, it's the same principle. You cannot change the size of an array, a standard array. Java does have a function called the array list, which we will be covering in future lectures. And the array list is something that is kind of like an array, but it's dynamic, so it kind of expands and contracts as you wish. But the way that you implement an array list is very different to how you implement a standard array. Now then, let's do another quick one. Let's see if we can get 39 people to do this. Let me new poll it. Oh, let me get this back. Okay, let's get as many people as in here if we can. Come on. Make me feel happy. Everyone got their computers out, everyone got their iPads, everyone got their phones. And if you want, really show off, you can, if you've got an iPad and a phone, and you've got a laptop, you can do it all free. And we can have like 600 people. Right? I'd be very excited to see that. Okay, let's see how we go on with this one. This one's a little bit tough, okay? Oh. Okay, I'll leave that off for now. If your class has a private string of s, instant variable, how would you write an accessor method to return the string to the user without causing a privacy leak? You guys didn't tell me you couldn't hear me. So how would you do it? See, it's louder now. You should have said. Okay. So A, strings are immutable, so it's okay just to return the array, S. B, make a new array, copy contents of S into it, and return the copy. C, use the copy constructor for arrays to copy over the array and return the copy. Or D, write the accessor to take an index I as input and return only S of I. Now imagine this is your exam question. I'll make your votes. Has everyone voted? I can almost foresee what's about to happen. Are we happy? Everyone happy? Yes. I knew. Well, 55, well done. I'm really pleased. There's more there. Right. So I'll keep that sort of down there. In fact, I'll move it away for now. Now, I've probably mentioned this before. The reason for the Homer Simpson is because back in the day when I was first doing this lecture, I was there sort of saying, can you think of the answer? Can you think of the answer? And everyone was laughing. And I was like, why are you laughing? What's so funny? I'd flicked on to the actual answer and couldn't see behind me. So now I put an extra slide with Homer Simpson thinking so that I see the yellow coming up, knowing that I flicked forward, and I don't have the same mess. So going back to here, let's just see if there's more update. Oh. Wow, I'm doing well. Okay, so majority saying B, and then with it sort of equal spread on C and D, some A, some pretty good going on E. Yeah, so let's answer them individually. So E isn't the case, because I don't have to explain that. The answer is a bit tricky because technically it's 2. So the answer could be B, but the better answer and the best option would likely be D. So let me try and make that smaller. There you are. You probably can't see that, can you? Nope. Oh dear. There you are. Okay, so B, yes, make a new array copy. Copy the contents of S into it and return the copy. That is a standard way of doing it, right? It is a standard way. Not always possible, depending on the size of the array. I would argue that maybe D would be a more suitable solution to most sort of problems like that. So A, strings are immutable, so it's okay just to return the array S. Well, no, because arrays are mutable, right? So if you return S, if you remember, you can still change the array, because the array S is the key. If you return an array, you can modify any value in there, so it doesn't protect the privacy leak. Use a copy of the constructor for arrays to copy over the array and return the copy. Not sure why that's not a possible option, but yeah, so if you had B or D, you did really well, and if you got E, you did incredibly well. So, okay. So I've already shown you this. This is the for each loop, which I've kind of already given an example of, but I'll just review the slides. I've lost my cursor. So this was from Java 5, a special form of loop. It's different to a for I, when you've got for int I from I less than 0 to some value, in that it makes a copy of each individual element on each iteration and allows you to manipulate that, which is what the example was I was showing you here. So this is the for each. So what this really means is, for each array in my person, for every single element, every single one of these, each loop will be P, it will be of type person, and for each one of those, you can do something with it. So that's a very useful function to use, the for each loop. And it's used more often because then you don't care how big the array is, you don't care how many iterations you're doing, you don't care how many steps you're doing, you don't care about the index. You literally just care about having the value and running something on that value and moving forward. So I think this is just an example. Oh no, this is multi-dimensional arrays. Okay, so multi-dimensional arrays, in Java, it's not quite a multi-dimensional array, so you don't really create a multi-dimensional array in much the same way as you would in another language. What is a multi-dimensional array? It's basically like saying, if you've got a list of, you remember the car park analogy, so you've got like, say, 10 cars, or 10 areas where you can keep a car of type car. You can have a 10 by 10 car park, so then you can sort of iterate through each row and column, if you will, or to any dimension. You could have 5, 6, 7 dimensions or more, whatever. Java doesn't really support multi-dimensional arrays, but you'd be forgiven for thinking it does. So on the surface, you can just create a multi-dimensional array, and how do we do that? So let's look at, let's just create where did we have the array? Okay, so this is where we had the array of Bob. What you can do is you can say, you can create an array, which is what we're doing here, and we'll just call it A. And that's just a normal array, like a list, right? It's almost like a list of elements. But you can actually say, you can do this, and now you have lists within lists. So essentially, here's the thing. So normally you can just put in 10 like this. I don't know if you can yet. So now I've got a 10 by 10 list of values within array A. So for every, it's kind of, you have to think of it like a grid, like a matrix, like a chessboard, if you will. And for every one row or every one column, you have 10 rows, right? Does that make sense? And it's much the same way. If you've used any language before, excuse me, if you've used any language before, you'll have come across multi-dimensional arrays. Essentially, the problem with Java is that it doesn't store, because an array can be of any object, it can't store a fixed amount of space for the array. So what it does is it holds a pointer. And then, so essentially what you can have, if I was to say like this, where I'm just giving a single value, that means I've got a list of 10 elements. In each of those elements, I can have another array. But each of those arrays can be staggered. You can have different length arrays. You can have different sort of values for those. And that causes a little bit of a headache in terms of the data structure. But in essence, if you have a 10 by 10 array, and then you say for I in the array, int A1 equals, yeah, so I'll just do that, and then I'll do for I again, which gives me the J. Then I say system.out, I don't know, print F. What have we got? Integers, so it's D, oops. So you're all familiar with what I'm doing here, right? So we'll run that. We got, oh, where's the exception? Runtime. What is it complaining about? I'm not sure what it's complaining about. All right, so I'll leave that as an example. I'll have a look at it later and review it, just looking at the time. So I'll put an example of a multi-point array for you later. In terms of time, I'm kind of quite, I know it's 1:15, but, okay, so after multi-dimensional arrays, essentially it's the same way. Oh, so just the points of reference. If you do have a multi-dimensional array, like this, oh, we don't have a B, okay, so that's what the problem is. Okay, so if we do have a multi-dimensional array, to access the multi-points, so if you wanted to access, if you were to say A, you could access each element in the array in much the same way, like this, right? No, it's not S, it's A, right? So what I'm doing there is I'm saying for element on the, let's call this one row, and in fact, let's just do that. Let's just say int row equals 10, and the reason I'm doing this is because it will make it more sensible. And int column equals 10, and then we have rows and columns. So does that make more sense, right? So then in row 4 and column 6, I'm adding element 45. And essentially that's the sort of basic method in which you access the multidimensional arrays. And that happens with, doesn't matter how many times, I think you can continue this process indefinitely, as long as you have memory. And you can keep increasing the dimensions depending on the needs of your project. Any questions on multi-dimensional arrays? No? Everyone happy? Pretty straightforward. Okay, so what we'll be covering, we'll probably end up covering it next week at the beginning of, we've got enumerated types, or enums. And sometimes it's slightly offsetting from an array, but an enum is a list of values that don't change. You can define values within your code that don't alter the values at all. So, for example, days of the week, you know, in any language, the days of the week remain the same, right? They don't change, just have the same values. And in such a case, you can define an enum, or an enumerated value, and an enum has certain attributes that makes it sort of a useful feature. We'll continue with enums, and there's only a few slides left, so we'll continue with enums next week, but we'll finish it off there. Just a quick reminder that obviously the 13th of September, your assignment 3 will be due in. So what is it now? It's the, what is it now? Is it the 9th? It's the 9th, right? Okay, so that's in what, 4 days. So do get onto that. I will make sure that any issues with the server are resolved in the next day. It shouldn't stop you working on the code, that's the point. So just because the submission might be a bit wonky, it shouldn't affect that. Your project will be released at the end of the week, and your project, the due date on your project is the 4th of October. So you essentially have just sort of a bit over 3 weeks, I guess, to complete that. The point of the project is that you can't really be late with it, because if you're late with a project, you will end up losing marks for the peer assessment because you won't be in the poll. Your name has to go into the pot to enable you to get the marks. So you need to have something to present after the 4th. Whether it works or not, it doesn't matter. What matters is that you've given some code in. I need it to work, really. I mean, I'm not giving you a way out. But I'll give you more details on that by the end of the week. Before we go, are there any questions at all from what we've covered so far? Everyone happy? All right, guys, I'll see you guys next week. Thank you.